Welcome, everybody. Good morning to the people who are attending from home and the people here in the room. Welcome to another seminar organized by the Abstraction Group, the ERC Grant Abstraction Project. And today we have the honor to host a colleague who is also a co-author, his name is Philipp Wicke, and he is assistant professor at the Ludwig Maximilian University in Munich, Germany. Tenure, congratulations. Philipp is working on a variety of topics that are related to computational linguistics, natural language processing, computational creativity, and artificial intelligence in general. He has obtained a PhD at the University College Dublin with a project on embodied storytelling using spatial metaphor and gesture. And for the linguists here in the room, he is member of the newly launched Munich Center for Linguistics, right? Promoted by the Faculty of Languages at the University of Munich to boost, and it's a center that has been established to boost interdisciplinary collaboration in the field of linguistics. So Philipp Wicke has a background in a variety of disciplines, and he is truly, I think, interdisciplinary in his research as he bridges and publishes works on topics that bridge linguistics as well as computer sciences and cognitive sciences, this triangulation somehow. I had the honor to collaborate with him on several occasions, and notably during the pandemic, we co-authored together a couple of studies on the COVID-related discourse on social media, and both studies have been very appreciated by various research communities, and they were cited a lot. So today's talk by Philipp is about exploring spatial intuitions and analogical reasoning in large language models. And without any further ado, I would let the floor to Philipp Wicke. Thank you for being here.
Thank you so much. I don't think I've ever got such a long, nice introduction. And first of all, thank you for inviting me. Finally, it happened. Yeah, I can close that. So yes, thank you, Mariana. I still remember I was in Ireland in my bachelor's when we met, and you were in a postdoc, I think. So now things have changed a lot. All right, okay, now let's talk about my research that I'm currently doing. So there are many different things happening here: spatial intuitions, analogical reasoning, large language models. And I want to start with large language models. Let's see if that works. So currently the field that I'm working on, or the department that I'm working on, is working on natural language processing. But as you may have noticed, natural language processing is mostly being consumed by large language models and studies on large language models these days. And the essential or the basic idea behind large language models is you take code, books, chats, texts, anything that is written or typed out by humans. You train a neural network, and this network then learns the patterns of the language, and then the resulting model is able to produce language. Right? We're not valuing this at any stage for now. We're just saying this is the basic idea. And there are two things to note about this. So the learning and training for these big and large language models capable of some form of language takes about 1 to 3 months, depending on the size and your compute and your capabilities. There's obviously models that train longer, maybe half a year. But what's cool about them, they can do weight sharing. That means if I have trained such model, say ChatGPT, right, I can just copy and paste all of the values from the model, and then I have another model with the same capabilities. So I can just copy the last state of the training, and then I have another model with the same capabilities. So now, if we look at human language acquisition, the whole training procedure is a bit different. call it training procedure, right? So we as humans, we have acoustic feedback, visual feedback, locomotive feedback. As children start to take up a language, they interact with the environment in order to understand and conceptualize what's happening around them. And then they integrate these things into language, mimicking language and so forth. There's a whole bunch of things happening in language acquisition. But then again, we have a training with a neural network, but this time in our brain, to learn the patterns of language. And this also results in a model with the ability to produce language. So now this, to put it mildly, is vastly inefficient because the learning and training completed, as Mariana can confirm, takes about 3 to 5 years. If you're lucky, right? It depends. There's big variation in how fast these models are learning the language. And then the problem is also you can't just copy, right? Once you have somebody who speaks a language, you can't just copy and paste it. If you make a new baby, you have to learn from scratch. Right? So you have to start all over again. And if you look at it from this way, then the human model is vastly inefficient with these two aspects. It takes super long, and you always have to start anew when you want to create a new language model, right? There's obviously some differences here, right? And how useful that is to start from scratch or not. But what I want to look at is this key difference in how these two models are learning from data. One model is just learning from text. I mean, there are obviously by now multimodal models that also learn from visual input and other kinds of input, but let's just stick with language models for now. So we take text, any kind of text, code, book, whatever, and we get our model. And then the human, rarely you will find it that a child takes up a book and learns language by reading the book. And we have this difference, right? So there's obviously a big gap between those two steps. But the end result, if you look at the benchmarks and evaluation that is out there, seems to be that the large language model can compete or sometimes even outperform human language performance on certain tasks, right? So on the surface level, we see this very, very great performance of large language models, but the underlying language acquisition mechanism, the training, the learning, whatever you want to call it, is vastly different. So my idea then is there has to be some fundamental difference between those two. And we can't really see it in the results of some tasks, but maybe we can see it in the results of some challenges that we pose to the model. But we would need to look at what are the things in our language, in our conceptualization, that are strongly influenced by these factors that are not included in the large language model. So visual, acoustic, sensory, and locomotive feedback, all of this I want to combine and say these are embodied experiences that are in the training of the human, and the large language model is trained without these embodied experiences. So the research question could be, is there a different result when training a large language or a language model with embodied experience, the human, versus training a language model without embodied experience, just the large language model? If you have any question at any point about any of the terms or whatever, interrupt me. If I'm using this wrongly in the context of, let's say, linguistics, please point it out to me, right? Because I have not studied linguistics per se, but, so I'm very grateful if you point out that there's something I should differentiate or explain further. Okay, so my first experiment, rather naively, I thought, okay, let's look at a task that is tricky for humans, but also tricky for a language model. And then we can change one of these parameters of embodiment and see if that maybe prevents the model from performing better or helps the model to perform better. So I looked at figurative language, because this is already a difficult task for humans and language models. And I started off with a figurative phrase. So here's an example. She dances like a fairy, and then the interpretation can be, this means she dances gracefully, and the alternative would be, this means she does not dance gracefully, right? There's, let's say, we binarize, and there's a correct and an incorrect interpretation. And there is a paper from 2022 testing the ability of large language models to interpret figurative language, where they create a corpus of figurative phrases. they are supposed to be not in the training data of the model, so the model has likely never seen those sentences. And then they prompt a bunch of different models for the interpretation and evaluate which of these sentences would the model choose more likely, the correct one or the incorrect one. And then they evaluate whether the model has this ability to interpret the figurative sentence. Turns out, what is known by now about many models, the larger the model, the better the model at doing this task. There's actually quite a good correlation with human response, but it's still not at the level of human interpretation capabilities. So that was my starting point. They had this nice data set. And now what I was interested in, as I said before, I wanted to evaluate what extent does embodiment play a role in this. So I looked at what's called the perceived embodiment of a word. That is a corpus by Paxman from the Paxman lab. And they have a list of ratings for the relative embodiment of verbs. So they ask a bunch of participants, how would you rate this verb, dancing, with respect to your perceived embodiment? And obviously something like dancing has a high score, or something like rumoring or something like this has a lower score. And so I took all of these annotations, and my idea was now I will look at how does the ability of the language model change if I keep varying the degree of embodiment in the sentence. And so here's the counter example. The pans were faded as the sun. The perceived embodiment of faded is only 2.4. And the interpretation could be wrong, right? So this is already showing you what I would expect the model to do. But kind of like the other way around, right? Here, this is more embodied. So I would expect the model to perform worse because the model has not learned maybe something about embodiment, and the model may be able to interpret the second one better or equally bad because there is less information in the embodiment here, or about the embodiment. So the hypothesis then was there is a correlation. I'm not directing it. I just say there is a correlation between the capabilities of the LLM and the ability to, between the LLM's interpretation capabilities of the metaphor and the amount of embodiment of the action in the metaphorical phrase. It's pretty straightforward. And I've also, you could think that, yeah, maybe the figurative phrase is a difficult phrase or a short phrase, or it has other properties that may influence this. So I accounted for all of these different properties. I've checked for all of these different right concreteness of the action in context. So I looked at what is the concreteness of this action, age of acquisition, length of the word, frequency. So I took all of these confound variables, making sure that if I check for the embodiment score, we're actually measuring what we want to measure. And for the interpretation side, I just check different model sizes and parameter counts. So you have to do. And these are the results. And obviously, I could not show what I wanted to show in the sense that the larger models starting from GPT-2 mid-sized model show a significant correlation between the embodiment rating and the ability to get the metaphor right. And the other, like frequency, age of acquisition, and length, do not show this effect. So it seems that there is some property about the perceived embodiment that enables larger language models to better interpret the metaphorical sentence. So it's actually the opposite of what I was hoping for, right? And now you can have many, many different hypotheses of why that is. And the easiest one, so to say, is that an embodied verb is more lexicalized in a way. We use it more often because it's also more embodied for us, something like this. And therefore, it's probably easier also for a model that has been trained on large amounts of data to also be able to predict the interpretation. But I did not follow up on this. It was a bit too frustrating to come up with the entire opposite of what I wanted to show. But it's not wrong, and it's also a good indication that at least this embodiment measure seems to be able to influence a task. I don't really know to what extent or why. Right? This is where the study stopped. So the more embodied the action word, the easier it is for the LLM to predict the figurative language. but take this with a grain of salt. It was like one sentence metaphors, and I only looked at the action verb. So I would not say that in general, the more embodied, the easier it gets for the model, but at least in this setup. Okay, so I crossed out figurative language and I turned to embodiment again. So there are many other hypotheses I can follow up on if I look at this, and I still want to compare. There has to be a difference in the conceptualization, right? If you only train on text, or if you have this whole complicated thing of like being a child and observing the environment and doing stuff with the environment and then acquiring language. So I looked at abstract spatial schemas. And this is where I really wanted to look at how is it that we actually learn. The pictures are a bit slower on the screen than on the screen, but you still get the idea. So in this example, you see that children, when they grow up, they often fall down on the floor, and being on the floor is not a nice experience, I guess, especially if you're trying to start walking. Whereas the opposite, you're being rewarded for your first steps, for reaching the juice bottle that's on the table you're not supposed to get, and stuff like this. So we earlier make a lot of these spatial experiences, and let's go to the next one. And they also then translate from like physical experiences to emotional experiences, right? So we already probably know where this is going, right? We have these mappings from something that is down, that is negative, and something that is up, that is positive, through our interactions with the environment. And we all share this notion because we perceive gravity in the same way, and the same way we perceive depth, and the same way we perceive social interactions. And there are a lot of these image schemas or spatial schemas that we experience as children when we grow up. And then they give us these building blocks, right? This is research by Mandler and colleagues, where they say, okay, we have these simplistic building blocks, and then from those we do spatial integrations, and they allow us to conceptualize the world. So here the baby learns something like, okay, there's a structure, and that structure gives me some support. It's very slow. Then we have other relations like source, path, goal. I have to take the food, I have to put it to my mouth, and then I reach my goal. And then we have something like containment, right? There are many of these fundamental schemas that we learn through our interaction with the environment. And then what we do from those abstract spatial schemas is we can form these conceptual metaphors where you can also lean on me if you need help. My head feels empty, right? It's also a containment. And then we do this integration from those spatial experiences to more abstract notions. Or emotional, to the emotional plane, let's put it like this. And we can also measure those or investigate those abstract spatial schemas in grown-ups, in humans, and see what are the shared spatial schemas that we have acquired through language or through interaction with the environment. So you can see here, this is an experimental setup done by Richardson and colleagues in 2001. Titled Language is Spatial, and you see those 4 items here, and participants are shown a word, and then participants need to pick one of those 4 images that corresponds mostly to the word. So, for example, if I have the word hoping, which of these images would you choose? A, B, C, or D? You can raise your hand. So the word would be hoping. Would you choose the image A? Would you choose the image B? C3, or peer pressure. That's everyone. C. Okay, thank you. And D. Okay. All right. I'm not even asking why, right? This will be a follow-up later on, but we can see that there are these intuitions that seem like there was a group that was more or less coherent. And Richardson did this with university students, of course, and the list of words was 30 verbs, and they were ranging from very concrete to very abstract. And they also had an implied directionality, implied because there is no factual connection between the word and the arrow. We assume that there is, and we have to hope that most people agree on our intuition, but essentially it's just a symbol that we assign meaning to it. And you can see, so this would be the explanation here. I've shortened the list so that it's 30. So for flat, pointed, pulled, pushed, walk, we assume a horizontal orientation. And you can see that most people, these are percentages, seem to cluster in this horizontal left-right connection if they are given instance. And neutral, we see mixed results, and then vertical, we see that it clusters in the vertical. I also did the analysis of like, obviously, more abstract has less correlation than more concrete, and so forth. Right? And what did we do with this? We simply collected the data from the original paper, and we got those distributions out. Okay, now what we can do is we can ask a language model to do the same task. I'll show you these 4 images, and you have to pick up. But this doesn't work because most language models work with text only, and we can't show 4 images. We also did this with a vision language model, so GPT-4 Vision, that we presented the images. But for textual analysis, we need to somehow textualize these arrows, and we've chosen 2 different strategies. One is we lexicalize them and say up, down, left, right. And this is not super nice, but the other version is, which we call like pseudo-visual, where we use the Unicode arrow, which is a literal arrow in text form, and then we pose this to the model. And this is a paper that I presented at ACL a few weeks ago. So the main figure where we say, okay, we have actually 3 different experiments. The one I showed you just now is one of the 3 experiments where we do this. But we also have 2 other experiments where we check for concepts like support or verticality, these other kind of spatial intuitions. And then we ask LLMs in humans, and we correlate the original psycholinguistic studies with the LLM results. And yeah, to no big surprise, again, larger models seem to perform more in line with humans than not. And they actually have a correlation score of 0.6 to 0.8 sometimes. So, yes. Is there a question?
There's a question, maybe later we can read it.
If it's not something about a word right now that I should, what is embodiment? Okay, then I will continue. So we did look at a different bunch of models, this little model zoo, and evaluated how the language models perform on these experiments. And we have a set of, the bold ones are the human responses, and the lighter ones are the LLM responses. It's hard to read, but we already have it on our webpage, and we have it, is it the next slide? I'll talk about the results, and you can explore all of the results on this website from the paper. You can click on all the different models and all the different conditions, and you can browse through all the experimental results. But I'd rather give you a table than a very long list of distributions. So in this table, and again, to focus your attention, to only highlight the most important section of the table. So here again, we have the lexicalized version, up, down, left, right. We have the arrows, up, down, left, right, up, down. And we only look at horizontal or vertical distribution. That was what the original paper also did, because otherwise we would do so many tests. And in this case, we just say, okay, does it get at least the horizontal or vertical alignment with human intuitions right? And we also check for images. So for the best results will be GPT-3, the instruct version, and it has a correlation of 0.72, significant one, which is a good correlation. And same with all the other conditions. When we turn to images, we see that there's a drop in the performance in the sense that correlates less with human responses. And if we looked at the 2 open source models we tested, they had absolutely no idea what we wanted from them, right? It was only at this moment GPT-4 Vision that could do some of the task, but we're already planning to do it with much better vision language models. But overall, the takeaway here is that, yes, they seem to correlate with human responses on this task, and that's great. But what does it even answer? What do we learn from that? Right? There are many of these psycholinguistic studies that these days that do these experiments with LLMs and say, okay, found they can do that, and then it stops. Right? So this was also feedback that we got and accepted, right? That, so what do we learn from this? Yeah. Yeah. So let's do another study. So if we look at the results individually, so if we do a bit of like a qualitative analysis, and you see, for example, bond. So again, the old one is human response, and the one next to it is the language model response. So you can see here that the language model for bond kind of, why do you see a distribution? Could be confusing. You see a distribution because, and this is a bit of methodology, we know that if I present to you A, B, C, D, if the model has no idea, it will always choose A because A is the first character in the alphabet or something. Right? It has no other idea, so it will choose always the same item. There's a bunch of papers that show that in multiple choice questionnaires, language models show a pattern of picking something. So if you ever do an LLM experiment with choosing something, always randomize your items. Otherwise, you will have a big bias or problem. So in order to randomize them, we have to run this 24 times, right? We have to do that 24 times and show all of these items in a different, all of these options in a different order. And that's why you get a distribution. So you see here that the distribution is almost equal. So again, the language model doesn't have an intuition, apparently, about what this word is connected to. Humans, on the other hand, have a strong intuition. They mostly agree that bomb is something falling down. But then again, if you ask humans about this, at the last conference, right, this is 20 participants. And at my paper, a poster presentation, I had more than 20 people, and some of them said, no, bombing is this one. And I asked them why, and they said, well, something blows up. I was like, yeah, that makes perfect sense, right? Yes? No.
But did you notice some differences in the background language of people?
That's, yeah, we'll come to that, right? So we also have something like many of the progress words, like hoping. Some people also said this one, because it's in the future, so I'm hoping for it. And for them, it's left to right, because this means progress, which can be vastly different if you have a script that goes the other way, right? Many interesting questions, but we never looked at them. We only said, okay, we look at some of the results, same with lifted, suddenly humans agree. And what I realized, and this is just anecdotally, but we're looking into why that is later on, that if there is so this is more of a hypothesis, if there is an action move that allows a different perspective, so if I see the bomb, then it explodes, I get up. If I am dropping the bomb, I get down. I also had people say bombing is this because something gets bombed away. So you can change the perspective, and all of a sudden you get a different spatial orientation. But lifted is always up. Even so, if you are lifting, if you're being lifted, you would always describe it as something going up. So I feel that there's a matter of perspective in these, at least comparing these two elements. But this was the first intuition of, okay, something's happening here. And what's happening here is people forming analogies between this thing and this word. So there seems to be an analogy mapping between this abstract concept and the concrete kind of action that is happening. And this is the link to the paper, and the video on my screen is a bit easier to see, but like on this webpage, you can check the textual, pseudo-visual, visual connection in all of these models, and you can explore all of the results by yourself and can see how the distribution changes for these models. And now I'm coming to analogical reasoning. So that's the latest edition. There was work I presented at HKI, and So we slightly adapted. And again, this was a very, very preliminary study. We're now conducting the actual study. But as a very first idea, I thought we pose the exact same prompt to the model that we have previously prompted. So given the concepts up, down, left, right, and so forth, for the concept that best represents the event and then the item, we now say explain the analogy, and then we say analogy colon. This is sort of like the instruction, right? So that the model more or less follows our instruction, then provide the concept, and then give the concept tag. So why we do it this way, for 3 reasons. First of all, you will see I've also added now all the other permutations. These are different prompts, so to say. So again, this is where I will point you if you ever do LLM experiments. Their large language models are not robust to multiple choice selectors. There's the paper reference. So the choice order influences the LLM's response severely, specifically if you have a task that is difficult. If it's a simple task, you will barely notice this effect because the language model is then just able to pick the right answer. But as soon as you have a task that is challenging to the language model, it may resort to just picking the first option all of the time, irrespective of the image that you show. So the second methodological thing we do here is this explain the analogy and then give the concept. And this is closely related to chain of thought prompting. You probably may be familiar with this term. Is anyone not familiar with chain of thought prompting? Okay, right. So in the same way, we first ask for the analogy and then we ask for the concept. And the hope is then that we're actually maybe able to get results that are more closer aligned to human responses, because we want the model to first do the analogical reasoning part and then give us the concept. And the third methodological trick that we do is this validity scoring. So we look at this Aher paper from 2023, where they call it using large language models to simulate multiple humans and replace human subject studies. Very ambitious. But what we took from this paper is this validation score strategy, where we're basically saying, and again, let's say you ask the model to rate a sentence on a scale from 1 to 7, and the model has no idea, right? But you also change the item order. You can never know, or let's say it's a true or false statement. And you give the option true or false, and you're checking which token is more likely, the token true or the token false. But what you not account for is, let's say that the token true has a higher probability of the model, but it's a very low probability. But then you realize if I would have said correct instead of true and wrong instead of false, suddenly wrong had a much, much, much higher probability because that was the initial token that the language model would choose, right? So there could be a token that you haven't tested for that is actually giving you a much higher validity because the model is more confident in choosing this token. So what we do then is to optimize the prompt ending, at least, or the way in which we are prompting. We take a bunch of these prompts and we iterate the structure of what we ask for, and we look at what is the structure that gives us the highest validity score on the tokens that we want to observe. So we can only do that if we know the token set, true, false, 1, 2, 3, 4, and so forth. If we ask for something more complex, like a textual explanation, we can no longer do that, but we have certain strategies to see how should we prompt the model before just naively prompting it. So these are the 3 methodological tricks that we apply for this analogical prompting. And this is the end result, sort of like the first page figure of this analogical prompting paper. So we now again have an action, let's say perched, and we want the LLM analogy. So before you read the analogy, think about it yourself. For perched, which of these 4 arrows would you choose? I often have the problem, most of my colleagues don't know what perched means. And then even some people, like I have a speaker of Farsi, and he doesn't even have a proper translation of the word in his language. It's another difficulty. So which one would you choose? Up, down, left, right for the word perched? Mariana?
I don't know, perched is out.
Okay, let's.
Oh.
So what did you say? Well, what was the translation? Can I hear the translation?
Dice arroccato.
What is that you were saying? Is that the same word, or are you giving an example?
When the board go to the.
So that's the problem, because everyone, as soon as they read this example, are changing something. Because now you can read this. So for me, perching is something where I would sit. So for me, intuitively, it's down because I'm perching.
Yeah.
But most people then, as soon as they read the example, they're like, yeah, okay, but it's a bird, so it's up. Which,
Well, but
Because of course,
I mean, long story short, there is no right or wrong answer to this.
The visual situation.
Aha.
but it depends.
Usually,
Simulation of the situation, not just the action.
probably the distribution of person is not aligned with
It
the
depends. Maybe you can visualize the action, visualize
that was exactly my point. The discussion is exactly where we want to have the study, right? So you can see here the LLM also chooses up and explains it much like a bird flying upwards to perch on a tree branch. Okay, I can agree with it, but I would also agree with if it would have said a bird sitting down on a branch high up in a tree, but I'm choosing down because it's sitting down. You could also feel that. I'm not sure, right? I'm not a native English speaker, so you get that the LLM comes up with an explanation and then chooses from this item. And if we have a discrepancy, we can now investigate the discrepancy. Where does it come from? So this gives us two chances. First, we can maybe achieve greater model alignment. That is, if we prompt it to first give us the analogy, then the model may make a better choice, a choice that closer aligns with human responses, if you want to say that this is better. For this or even for other tasks. Same with the chain of thought prompting, right? So that was basically the idea of chain of thought. If we first ask the model to reason about the problem, it gives us better results overall. And then it also allows us explainable responses that provide access into some surface level understanding. So we can, on the surface level, understand why the model has chosen this. And here on this table, you can see this is the model prompted correlation scores without an analogical prompt, and then with a, and on average, we see it increases the correlation between human responses and model responses. I would say that this is a reasonable increase. Reviewers said it's not. But again, this was the very first time we kind of like just took some model and threw the first prompt that came to our mind, and we could immediately see, okay, at least there is an increase, and almost across the board. For these Unicodes, it was for all of the conditions. Right. So there seems to be an effect. We have to study it closer and check for its significance across different models, different tasks. And then what can we learn if we inspect the individual elements? So again, this was the example, and I'm just showing you some answers from models to this. So let's say up is associated with, what was the word here? In many cultures and languages, the concept of increase is often associated with the direction up. This is because we visualize increase. We often think of things growing, moving upwards. Well, okay, this seems to align. But then think about the Chinese stock market. Right? You have different kind of at least color notations. You can think about up and down in different ways. There's time and space seems to be encoded culturally differently as well, right? Next one, perching. There is my example. Maybe by now, sometimes I believe I'm the only one who thinks perching is down, because yeah, for me this was not intuitive. So perching is similar to up, as it involves upward movement or position, much like a bird flying upwards to perch. Okay, And then we have these very ambiguous ones. Hoping, this was for asking for the word hoping, often goes looking forward to something in the future. That was what I meant before, right? So it's sort of like looking ahead. And yeah, humans can have different intuitions about that, as we know, this kind of left or right scriptures influencing these decisions. And here's another. So if you go to the website of the updated, the analogical paper, you will find the results that you can also flick through. That's much smoother. Of the different models and the different conditions, and you can see differences or alignment when you do this analogical prompting. But overall, it should be more closer aligned to human responses than if we don't do them. So the next steps of the study, which we are right now in the making, is gather human analogical reasoning, because that's what we don't have. We want to know exactly what I just asked you. Why do you choose this? So we also will first ask the humans for the analogy, and then ask for the concept. Turns out I took the exact same study, the exact same prompt that I gave to the language model, and gave it to one of my friends, and he could not do the task. I explicitly asked in this forum if he knows what an analogy is, and he said yes. And what he did was he would say, so let's say bond, he would say, well, this one thing, and you can see that there were squares and circles in the original stimuli. And he would say, well, this square is throwing a bomb to the circle. So he would literally just describe what he sees in the image in order to explain the concept. But he would not give an elaborate analogy of what he experiences that this is. So I realize now that a language model follows much closer the instructions given than a human would follow the instruction. The human then has like any idea of like, okay, you want me to pick something, so I'm just invent a story that explains my concept or my choice. So now we're adapting this prompt, and it's not as simple, right? So we need to give an example, but we can't really give an example, as you've seen earlier. If we give an example saying something like, well, a bird perches up on a tree, now you've introduced the directionality that will be the blueprint for every other decision that will follow. Same with if you say something like an abstract word like success, and you choose right because right is something positive, you know, like to progress or something. Now you immediately have encoded this kind of analogical strategy, and people will then be biased by this one example. It's the same with one-shot or two-shot prompting with the language model. You have to be very careful of the stimuli you choose as the example. So now we're constructing an example that is within the same space, but has very different stimuli in order to help my friend choose the right analogy. And we can also provide a definition. We can say, an analogy is when you, and then we provide a definition and hope that then the human will be able to solve the task. Obviously, this hopefully leads to an even better correlation of the model, right? If the model now gets the same one-shot definition of an analogy, maybe it's better at formulating the analogy. So right now we are trying to gather analogical reasoning by humans, also again for those 30 verbs, and then as many people as we can gather. And then we also want to include vision language models to conduct further experiments. So we also want to look at, let's say, clip and just see how does the arrow compare to the word and stuff like that. So we have many ideas for this. And then once this basic steps are done, we would really like to get into a whole multicultural domain or multilingual domain, and then do the same experiments, but with monolingual models of different languages or with multilingual models of different languages, and prompt them in a different language. And also ask humans that speak a different language or that have a different native language, whether their reasoning or their choices deviate from those choices. And I think this brings me closer to the initial big picture of like, okay, there's something encoded in these spatial intuitions that may be missing in the language model. So far, it seems that the language model is still pretty good at correlating with human responses. But I think if I go to like a multilingual perspective, I can maybe at least poke a few more holes into the results. And right, this is now, I'm done with the main part on the analogical reasoning, but I wanted to like show you what we also work on. So this is the last slide on what we also work on. We also have a robotics team in our lab where we collaborate with the technical university. And this is related, right? It's not so far away. So we have a robot do a bunch of tasks. They're very simple pick and place tasks. So pick the, what is this? Move all the warm blocks on the bottom left area to the top right area. And this is playing on a lot of understandings. What is warm in the concept of like colors, and what is top right in the concept of this image. And then the robot needs to do the task. So we have a set of reasoning capabilities, or we call them perceptual reasoning capabilities, right? Where something like color, size, spatiality, reference, and common sense matters. And then the robot needs to solve this task. And then this is the related work, this Loho-Ravens long horizon benchmark, where the robot needs to combine these different reasoning strategies in order to solve a set of simple pick and place tasks. Just to show that we also do a bunch of other things. And that's it.
Brilliant. Thank you so much. Let's see, we can always stop sharing the screen.
I should stop sharing this one.
Yes, so that we can see. So in the chat, there might be comments from the chat. Giovanni Corazza, I have to be very look for the recording to comment that LLMs can only infer spatially embedded experiences by their extent descriptions in language. However, there are researchers and companies that are working on spatial intelligence trying to train networks on data collected via sensors moving in a 3D environment, for example, on a robot. Yeah, you have spoken about it in the last slide. Yeah, it's more a comment than a question.
And I think I covered that.
You covered that, yes. I think he had to leave before, so thank you. And I have a comment, a question.
Yes.
So thank you very much for the very extensive overview. And of course, when we talk about embodiment, I think somebody said that the number of definitions of embodiment that you can find in the literature equals the number of researchers working on embodiment. So every person has their own definition of what embodiment means. And in your study, it seems to be related to actually perceptual actions, like actions that are more concrete and have to do with perception, as opposed to actions that are more abstract and so forth. Would you say that this is your working definition of embodiment, or?
I don't know. I mean, it's hard to define. I would not agree with this statement. I would not say that only more concrete actions are more embodied. Right? This is kind of what the study, this relative embodiment or perceived embodiment study shows. If you look at the data, how at least humans perceive that. But to be fair, if you just ask some random people how much this action relates to their body, that's not what I would say is embodiment. Right? Okay. For me, embodiment comes maybe also from more of the computational side. That you say, if you want to understand cognition, it's not enough to look at brain signals, but you have to understand cognition as a phenomenon that is a coupling between the environment and the brain. So it's more like an extended way of looking at computational processes in the brain.
That's a nice definition. Yes, I like it. Yeah. Thank you. Another question?
Yes.
Volume su.
I have a question. So thank you for your talk. Very extensive, as Mariana said, interesting. I have a question about the difference between the schema related to the to bomb or to lift. If have you considered the fact that maybe some the lexical information are also the semantic neighbors are different from one word to the other word, because as you say, we have a different perspective for bomb, because we are already encoded in language some sensorial and perceptual information as a bomb from the sky, a bomb in the middle of the square. But with leaf, we have less problems, less perspective, because we have the lift up or lift from the ground. So we have already a schema included in our linguistic experience.
Thank you for the question. I think we should be careful to not rely on our own intuitions with this, in the sense that, I mean, I can probably think of many more scenarios in which I lift things on a daily basis than I see something being bombed or bombing, right? It's much more concrete in the instance when something's bombed, and it's probably more reported on than if I lift my bottle. But in a text in general, like the lexical entries of lifting in any different context, who knows how statistically more likely they are and how much more they are decoding. So that's why I really want to look at how humans are actually saying that, right? Maybe there is a bigger diversity. Maybe they will all say lifting means lifting a bottle, but maybe everyone will have a different kind of example for lifting if they draw the analogy. And with bombing, could be that there's two perspectives, something being bombed and something dropping a bomb. And then we have a much smaller diversity. So after my Perched disaster, I really would like to focus on what the results will tell me, and I will be careful with assuming, but I mean, definitely your question is wrong. Yes, there's definitely some difference, I assume there is some difference, but how to measure it, I want to rely on the data that I will get.
Thank you.
I just have a follow-up question about this topic, because while you were showing us the stimuli, I noticed that you were using just the single word.
Yes.
Representing an action. And the problem with actions is that with verbs in general is that semantic of verb is not, how can I say, it is not really not independent. You cannot understand the meaning of a verb just from the surface of it, of the word. While with using the noun, for example, you can more precisely understand if you're referring to, for example, if I say dog, 99% of the case, you're going to imagine an animal. But maybe I can also think about someone that is a dog, just to say it's not a good person, but that is not something that you pick up from your collection of meanings from immediately, because let's say it's more prototypical meaning with dog, with the animal. And for this reason, with verbs you can't do that basically, because it depends on the context a lot.
Yeah.
So why did you not consider context, also a very short context like a verb and team, for example, verb and object, just to explain better what you were looking at?
Yeah, the original study by Richardson shows these squares. Do you see that on the slides? So it would say square, bomb, circle. That is the context provided. I agree that this is probably not the context you mean, right? But then again, you could all do this task without the context and you still agreed on things. It's really more about the intuition about this rather than figuring out how do people agree on this word in this context, on this specific unit that has this meaning. It's really more about the general intuition that people have. Also, you can look at it the other way around. Maybe we look at how do these 4 image schemas group all of these things, rather than how does this word attract an image schema? Does that make sense? And those 4 image schemas are inherently context. You don't want context for them. They're image schemas, they're these spatial schemas, and you just want to see what are the words forming this kind of image or forming around this image schema, instead of looking at one action word. Make sense?
Yeah.
I have another. Oh.
It is just, thank you for your talk. It was just like a question if you think also to expand the original data center or still working with it. So the PERCH example is just like maybe also different kind of obstacle that maybe enrich a bit the just question.
Yeah, I mean, it's a good question, but it has many aspects to it. First, if I rely on the original study, I have a reference point, okay? And I can always compare with the results, something like this. I could think of like expanding this. Let's say I have 3,000 of those words, right? I can just take a dictionary and pull the words, something like this. But then there's also a computational explosion. If you do for 3,000 words, 10 models, 24 different options, this is going to be a very expensive kind of experiment that you have to run. And what is it that you gain? You probably gain a bit more statistical robustness. But let's do it with this first and then see, right, if there's no statistical significance or we can see that there are trends, then I want to like, I would love to expand it. But even this 30 words, I can show to a single person and they can do that in 5 minutes and give me the analogies. If I show them 3,000.
Yeah, not maybe 3,000, but maybe there are some particular that could be like better chosen or some.
I agree, but then I would again need to compete with the original data set, and I'd rather stick with I have the data. But I also think that the original data set, the 30 verbs, they don't give any explanation how they chose those words. They don't really explain this is all aggregated scores. There's no standard deviation reported. It's 20 students. You don't know the gender or the language, native language.
Last question.
Sorry, I have one question is about the possible interpretations within the same language. So because you talked about trying to experiment on other languages, other cultures, my question is how do you account for the different interpretations for the same concept? Maybe like there isn't one single right answer, but there is a prevalent one, and there are like multiple possible ones based on the perspective.
Yeah.
So like, how do you account for that?
Yeah.
How do you
What do we make of the data that we get, basically, right? So we done this with at least with the language model, because the language model already has different analogies. Even for the same word, sometimes it would come up with a different explanation. And so we will find this in this short paper. We do a quantitative analysis, I showed that, and we also do a bit of a qualitative analysis. One colleague went through all of the analogies, and they are grouping around certain trends. So, for example, this word that right is closely related to wrong or right. So right also is connotated with any kind of like the right way, the right choice. And then everything positive was cluttered in these kind of analogy space. And then there was something like this, as I said, like left to right is a development, is a progress. So there will be themes or meta clusters or something like this that we will need to group around this. And then for different languages, this will be equally interesting. And see how prevalent are these trends across different languages. Maybe other languages will have different interpretations. Yes.
Okay. Thank you very much. Again, thank you. And thank you to all the participants from remote. It was nice to see you. The talk will be posted on the Abstraction website as